Algebra Checkpoint 7b, Systems of Equations. A system of equations is a set of two or more equations that are given together. Solving the system means finding the point that will work for both equations. We call this the point of intersection. Systems have one of three solutions. They intersect at exactly one point, which we call independent, and we'll be looking at that in a minute. They do not intersect at all when the lines are parallel, which has no solution. They intersect for all points, which means the lines are the same and they are all real numbers. This video is going to focus on when they intersect at exactly one point. There's three ways to solve a system. The first way is substitution, where you substitute one equation into the other. What you're going to look for substitution is having one equation equal to x or y. That's the sign that you should be solving by substitution. The second way is going to be elimination. You're going to add or subtract the equations so that the variable is eliminated. Look for one set of variables having the same coefficient. Please note, sometimes you will need to multiply an equation or both by a constant in order to be able to eliminate the equation. And then the last way is graphically. You're going to graph the set of equations and then find their intersection point. What you're going to look for that one is if both equations are equal to y. Graphing is probably the way you want to go. So let's do a couple examples. Example number 1. Solve the following system. 4x plus y equals 8. X equals 5 minus y. So hopefully you've already thought to yourself that this is a substitution problem, because you can see x equals 5 minus y. So we're going to take 5 minus y and we're going to replace x with it. So I have 4 times the quantity, 5 minus y plus y equals 8. And again, I'm just replacing my x value with 5 minus y. Remember, you need to multiply both of these by 4. So I have 4 times 5, which is 20. And I have 4 times negative y, which is negative 4y. And I'm just going to bring everything else down. The next thing you want to do is combine your like terms. Negative 4y plus y will give you negative 3y. We're going to keep solving, so I'm going to subtract 20 from both sides. Remember, you need to bring the negative down, so I should have a negative 3y. A lot of students will just bring the 3y down and forget the negative, which is going to give you a different answer. 8 minus 20 will give me negative 12. So I'm going to divide both sides by negative 3. So I get y equals positive 4. Remember, a negative divided by a negative is a positive. However, you're not done yet, as you need to take y equals 4 and substitute it back in to your original equation. We need to do this so we can find the x variable. So I have x equals 5 minus 4, since my y value is 4. 5 minus 4 is 1. So we think our answer is 1, 4. Now the last step you need to do, which many students forget, is to check your work. So we're going to plug 1 in for x for both of these, and 4 in for y for both of these, and see the answer that we get. So I have 4 times 1 plus 4, and we want to see if that gives me 8. 4 times 1 is 4, plus 4 is 8. So you can go ahead and just give yourself a check mark. Then we have 1 equals 5 minus 4. 5 minus 4 is 1, so I can give myself a check mark. So we know this one is the answer. You want to make sure you get in the habit of checking your answer, so that way when you're taking this on an individual or a team test, you will make sure you have the right answer before you turn it in to grade. Let's take a look at another one. Example number 2. Solve the following system. Negative 2x plus y equals negative 7. 3x minus 4y equals 8. This one you could solve in a couple different ways. You could add 2x to both sides and then substitute 2x minus 7 in for y for the second equation. But I'm going to do this one as elimination, so that way you have an example of each. However, you probably noticed negative 2 and 3 are not the same coefficients, and 1y and negative 4y are not the same coefficients. So I'm going to multiply my top equation by 4, because that's going to give me a 4y here, which will match my negative 4y. I don't need to worry about my x's right now. I do need to remember that I need to distribute the 4 to all 3 of them. So 4 times negative 2x gives me negative 8x. 4 times y gives you 4y. And 4 times negative 7 gives you negative 28. I'm then just going to break the other equation down. So I have 3x minus 4y equals 8. A lot of students ask when they should use addition or subtraction. If your signs are opposites like this, you're going to want to add your two equations. If you have the same sign, either positive 4y and positive 4y, or negative 4y and negative 4y, you're going to want to subtract them as well. So, and remember, you're adding everything. So negative 8x plus 3x will give you negative 5x. 4y plus negative 4y is 0. Negative 28 plus 8 is negative 20. You divide both sides by negative 5. So you get x equals 4. Again, we need to solve for y. So you're going to take your x equals 4, and you're going to substitute it into one of the equations. It doesn't matter which equation you use, it should work for both of them. I'm going to do the first one. So I have negative 2 times 4 plus y equals negative 7. And again, I'm just taking 4 and I'm substituting it back into my original equation. Negative 2 times 4 is going to give me a negative 8 plus y equals negative 7. So we're going to add 8 to both sides, so I get y equals positive 1. So I think my solution is 4, 1. But of course, I want to check and make sure my answer is correct. So I have negative 2 times 4 plus 1, and I want to see if that gives me negative 7. Negative 2 times 4 is negative 8, plus 1 is a negative 7. So it works for that one. Then I have 3 times 4 minus 4 times 1, and I want to see if that's going to give me an 8. So, 3 times 4 is 12, 4 times 1 is 4, 12 minus 4 is 8, so it works. So I know this is my final answer. Now the last one is graphing. And personally, I like graphing the best. I think it's actually the easiest way to do these problems. So for the equation y equals 2x minus 7, hopefully you remember that we're going to start here at my y-intercept of negative 7. So I go down. 1, 2, 3, 4, 5, 6, 7. When you have a slope of 2, 2 is the same as 2 over 1. So I'm going to go from this point up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. You don't need to do quite so many points, but it does help. So I always like to do several points just to make sure my lines are really straight. The big key with graphing is you want to make sure that your lines are really well drawn, because then it's going to make the intersection point really obvious. Now for my second equation, I have y equals x minus 4. So my y-intercept this time is at negative 4. So I'm going to start here at 1, 2, 3, 4. And then remember that we don't write the number 1 in front of here, but it's there. So if I have x, that's the same as 1x. You can write a 1 in front of the x if you want to, and there's nothing wrong with doing that. So again, my slope is going to be 1 over 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, and I think we can already see where the intersection point is going to be. And then I'm going to draw my line. Alright. So you hopefully already noticed that your intersection intersection point is here at the point 3, 1. 3, negative 1. But again, you want to make sure you check your answer because you might make a mistake like that. You know the point's here and it's at 3, negative 1, but you accidentally put 3, 1, and you want to make sure to get all your points. So let's check our answer really quickly. So I have negative 1 should equal 2 times 3 minus 7. 2 times 3 is 6. 6 minus 7 is negative 1, so it works for that one. And then for my other one, I have negative 1 equals 3 minus 4. 3 minus 4 is negative 1, so it works. So again, I have my final answer. Hopefully that provided a nice review for you on how to solve a system of equations. If you have any questions, you are always free to email me at mbrener@d131.org for more help.